The density of polystyrene with 2 repeat carbons is 3.45 grams per cubic centimeter. What is the lattice parameter C if A equals 17.2 nanometers and B equals 2.4 nanometers? To start this question off, I'm going to go ahead and say that example problems aren't always realistic. For this one, we can assume that they're talking about a crystalline region of the polymer. However, if you get an example problem where the numbers don't make sense or the question doesn't necessarily make sense itself, you can go ahead and solve it for the process because your professor or teacher probably wrote it, assuming that you would solve for the process and to understand the content, as opposed to it being a realistic problem. So we're going to go ahead and start. When you have a polymer problem, you generally want to know what the monomer looks like. So for polystyrene, this one goes ahead and tells us that there's 2 repeat carbons, and polystyrene has 1 aromatic ring on the bottom. So we're going to go ahead and find the molecular weight of each monomer. And to do that, we're going to start by counting carbons. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go ahead and write down 8 carbons. And then we have to add in the hydrogens. And remember that hydrogens don't always have to be drawn in, but we can go ahead and complete the ring if we have it like this, and then we can see where the hydrogens would be. So we'd have 1 here, 1 here, 1 here, and then we've got hydrogens around the ring as well. So we've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So you're going to want to get used to finding the monomer weight for a polymer for almost every problem you do. It's good to have as knowledge. You might not necessarily need it. However, again, you might need it later, and so you might as well solve for it in the beginning. If you don't happen to know the structure off the top of your head, you can look it up, or you can always ask your professor during the test. They should be able to give that to you unless it's clarified that you needed to memorize them. So in this problem, it gives us the density right here. This is the key part of the problem. So what equation are we going to use? We're going to need to use this density, so we're going to use the theoretical density equation. So if you remember, that is rho equals N times your monomer weight, and then we've got volume times Avogadro's number. And this is our theoretical density equation. So to start off, we can just plug in what we know and what we're solving for. So we can start off by plugging in our 3.45 as our density equals N. In this case, our N is 2 times our molecular weight, which is this added up. If you go and add this up, you're going to get 104 grams per mole. So 2 times 104 grams per mole over V. We don't know that, and we always know Avogadro's number. So this gives us a hint that what we need to solve for is V. So if we separate this out, we can solve for V. We just have to get V alone on one side. So we're just going to switch the spots. Got V equals 2 times 104 over 3.45 times 6.02. There we go. And this gives us V, which in this case, you can solve it yourself to check, but it's going to be 9.98 times 10 to the negative 22nd. And if we check the units, go through, this is going to be in centimeters cubed. You can go ahead and check those units as well. And it's asking us to find the lattice parameter. So how are we going to do this from volume? From volume, we know that the volume is equal to the product of the lattice parameters. And so we know volume, we know A, and we know B. So we can go ahead and plug it in and find for C. So C is equal to V divided by A times B. We can plug in what we know. C equals 9.98 times 10 to the negative 22nd over times 2.4. And before you solve this, check your units. So we have the top in centimeters cubed, the bottom in nanometers. You're going to want to change that both into the same unit. You can either do meters so that you have a base unit, or you could do centimeters. That would probably be the next easiest. And then you're going to go ahead and solve for C. I'll let you do that on your own, but you should be able to just plug it in.